A very good morning. We are from Group 11 from course BMM3741 Intermediate Six Sigma, and this is the project presentation for our group. Okay, let me introduce myself. My name is Oh Sun Yang. Together with me are Oi Sun Wei, Agidan, and Lau Kai Xian.
Hi, I'm Hui Sun Wei, manager of MK24051. Okay, I'm going to explain the design of the baseline and improve design. Okay, for the baseline, we use two plastic bottle cap and tape together with a theatrical tape, and we start with a wooden lower axis. When we tested, we found three major flaws. First, center of gravity was too high, causing the state wobbling. Second, it was too light to make it momentum. Third, the flat wooden tape create massive friction against the floor, basically hitting the plate and causing us to fail the 35-second limit. Okay, now I will explain the improved design. For the improved design, first we lower the cap on the drawer, disturb the center of gravity, and completely curl the long wobble. Second, we wrap rubber band around the outside. This push the mesh to the outer edge, increase rotational inertia like a flywheel, so it's being much longer. And lastly, we sharpen the tape to reduce the surface contact and friction drag. This three sustainable adjustment easily push our spin time well past the 30-second bracket.
This is our baseline data, as you can see in the table. So for the 10 tests run falling below the 35 second, which is LSL, and 3 of them is classified as a scrap and 7 of them is rework. So we have a resulting in 100% defect rate. So the process mean about 21.4 second and a CPK of negative 0.559 confirm as a critically incapable process, generating an annual COPQ of 354,000 cost due to the excessive rework and scrap loss across the projected production volume of 120,000 units. So after the improve, by assist a tape sharpening, symmetrical rubber band buster, and the center of gravity disposition, or the 10 variation runs fully assess the 13-second target, which in the range about 30.16 to 35.1 second. So the defect rate dropped to the 0%, and the capability improved dramatically from the negative to positive 1.286, so confirming a statistical capable process.
The expected overall ROI over 3 years period was calculated based on a targeted 20% COPQ reduction yielding over projected annual savings of over 70,000. Over the 3 years, this amount to more than 200,000 in savings. After reduction from the total project, we were of 80,000. The net profit was 100,000, 32K, 400 which was projected, resulting in a net ROI of 165.5. With the annual saving of 352,000 achieved through complete defect elimination accumulation over 3 year savings, we've reached 1,062,000 after deduction of the project. The net yield profit was 982,000, and the ROI from this was 1,227%. This significantly outperformed the projected ROI by which was 165.5%, as improvement eliminated 100% of defects and achieved the targeted 20% goal, with delivering also the 80% invested returns, more than 12 times. There are a total of 3 different Six Sigma implementations, which was the pivot interface material, perimeter mass distribution, as well as the center of gravity of height, and as well as gyroscope stability. For the first, being the pivot interface material, we used wood, which is naturally fibrous and has a lot of porous material microscopically. It produces high coefficient of sliding UK as it rotates, as the top rotates. A rough wood to surface ratio contact will cause a lot of breaking torque, and this frictional resistance rapidly turns the wheel rotating kinetic energy into thermal energy, causing the velocity to decrease significantly. Moving on, it is the mass distribution and rotational. The top has considerable radial eccentric because of the weights not being equally placed. As such, the max majority axis in inertia diverged from the actual geometric axis, causing asymmetric symmetry as a result, resulting in dynamic imbalance, causing the axle to wobble. Last is the center of gravity, height, as well as gyroscopic stability. A spinning rigid body, gyroscopic restoring torque is reduced when its center of gravity is elevated. As such, we modified the pin, the wooden bowl, to be higher. As such, the center of gravity would be lower to reduce the amount of friction, as well as COG, the center of gravity, so thereby reducing chances of instability.
Okay, let's look at our process capability. Initially, our baseline design was heavily incapable with a negative CPK of minus 0.559. The mean spin time was only 21.4 seconds, meaning 0 run met our 25-second lower specification limit. So to fix this, we moved through the Six Sigma analyze and improve stages to optimize the design. As a result, we successfully shift the mean spin time up to 32.73 seconds. More importantly, our new CPK reached 1.286, officially evaluating the process to highly capable. We achieved these capability gains by targeting 3 key design of experimental factors while strictly using recycled materials. First, we lowered the plastic caps along the wooden door axis. This optimized our center of gravity and eliminate initial wobble. Second, we added tightly layered rubber bands as an outer edge ballast. This increased rotational inertia, allowing the top to conserve momentum much longer. And finally, we sharpened the wooden tip to reduce friction. Minimizing this contact area prevented premature deceleration. Together, this mechanical adjustment unlocked our performance jump. Ultimately, this engineering improvement drove massive financial value. Our baseline process suffered from a 100% rework and scrap rate, draining $354,000 annually in cost of poor quality. Our optimized design achieved a 0% defect rate during validation, wiping out those losses entirely. against a total project cost of $80,000, saving $354,000 a year yields an exceptional 1,227.5% ROI over 3 years. With a break-even point of just 2.7 months, this project proves the immense economic value of data-driven process optimization. As a nutshell, our optimization project was a definitive success across all key project goals, which is the first one, target spin time, we achieved, successfully reaching a new mean of 32.73 seconds. And the second one, process stability, we achieved completely wiping out defects from 100% down to 0% and shifting our CPK from a negative 0.559 to a highly capable 1.286. And the third one, financial goal, we exceeded. While we originally targeted a modest 20% COPQ reduction, we actualized a full 100% reduction, which yielding 354,000 in an annual savings. This proved our Six Sigma implementation successfully transformed a heavily incapable process into a highly efficient, high return operation. And thank you, that's all for our group.